Jonathan Wellness TV. Today what we're going to talk about is circadian rhythms and how circadian rhythms are so important to our health and overall well-being. Hope you guys enjoyed the presentation and I'll speak to you at the end. Okay guys, so again what we're discussing in this episode is circadian rhythms. So again, if we look at the athletic development hierarchy, you can see that circadian rhythms is on the foundation of the hierarchy, along with nutrition, supplementation and lifestyle that we covered in the previous episode, and also with mental, emotional and spiritual health that we will be covering in the next episode. So circadian what? So when I say circadian rhythms, people don't really know what I'm talking about. So all circadian rhythms are your sleep-wake cycles, your day-night cycles. And the key thing to remember here is we evolved with the day-night cycles. So your circadian rhythm controls almost everything, okay? Your hormone regulation, your neurotransmitter regulation, your immune system. So your circadian rhythms are very, very important to your overall health and well-being. So modern chronic degenerative diseases. So when we're talking about chronic degenerative disease, we're talking about things like obesity, type 2 diabetes, mental health, heart disease and cancer. And what we want to do here is show how mismatches in circadian rhythm and circadian biology can contribute to these chronic degenerative diseases. Obesity, type 2 diabetes, the yin-yang of circadian biology, summer, which equals feast. Summer was a warm, adaptive environment, and we ran our bodies through glucose metabolism. Summer equals long days and short nights. Long days equals more daylight. More daylight equals higher cortisol, and higher cortisol means higher insulin. Higher insulin cortisol mobilizes more blood sugar. There was also more carbohydrate availability, which increased the levels of insulin, so we had higher insulin levels. Summer was a hyper-metabolic state because there was more food availability, particularly carbohydrate. Higher insulin caused weight gain in preparation for winter hibernation. So longer day equals less melatonin secretion at night and less prolactin secretion at night and more throughout the day. More prolactin secretion throughout the day equals a higher appetite, particularly for carbohydrates. You had higher immune activity, and if this immune activity is prolonged, it can cause autoimmunity. There was also increased sex hormone production and increased reproductive activity. Insulin resistance, type 2 diabetes, and weight gain, obesity, were perennial adaptations for the winter and famine that is about to come. Insulin has antifreeze properties that help the cell survive extremely cold conditions. So type 2 diabetes and obesity were reversed with cold and darkness. So what we're going to talk about now is obesity, type 2 diabetes, the yin-yang of circadian biology, winter, which is famine. Winter was a cold, adaptive environment, and we ran our bodies on free fatty acids and ketone metabolism. Winter was short days and long nights. Long nights equals more darkness. More darkness meant more melatonin at night. More melatonin at night meant less prolactin throughout the day. Less prolactin throughout the day and more at night decreased our appetite, particularly for carbohydrates, because in the winter time there's little to no carbohydrates available. Also, there was less sex hormone release and less reproductive activity. Increased prolactin secretion at night helps us have stronger natural killer cells and T cells. More melatonin, and melatonin is one of the most powerful antioxidants in the body, helped to decrease our body temperature, which decreased our metabolism and decreased our appetite. So winter was a hypo-metabolic state because there was food scarcity. So the overall summary is that in the summer, when the days were long and the nights were short and carbohydrate availability was high, we ran our bodies on glucose. Sex hormone output was high and reproduction was high. And because of the long day and high carbohydrate availability, this caused us to become insulin resistant, to gain weight, and for our cholesterol to elevate. And these were perennial adaptations for the winter and famine to come. In the winter time, when the days were short and the nights were long and there was low to no carbohydrate availability, we ran our bodies on free fatty acid and ketones. There was low sex hormone output and low reproduction because of the scarcity in food, particularly carbohydrates. Our insulin resistance, our weight gain and our high cholesterol were all reversed in the winter famine. They were all reversed by sleep, darkness and cold. Mental health and circadian biology. So here we're going to talk about serotonin, dopamine and bipolar. Primitive drives and emotions that govern sleep, mood, appetite, arousal, pain, aggression and suicidal behavior are all under the control of serotonin and dopamine. Dopamine controls reward pathways for memories and time perception with cortisol. Long daylight equals more dopamine. This increases hunger and alertness and allows us to learn and remember. Long daylight equals high dopamine, low serotonin, and this is a normal state. Dopamine makes light seductive and addictive. This is why it's hard to turn off the TV and the computer at nighttime. Dopamine also controls protein cravings. Dopamine brings everything into a sharp focus. Serotonin, on the other hand, is in control of impulse control, and serotonin blunts memory retrieval, slows the GI tract, causes vasoconstriction and blood clotting. Abnormal daytime serotonin levels cause withdrawal, immobility, and defensiveness. Normal serotonin function keeps the instincts for drives like eating, sex, and aggression subdued just enough but not too much for survival. So long daylight equals more carbohydrate. More carbohydrate equals high insulin, and high insulin goes hand in hand with high serotonin. Insulin converts protein, amino acids, into serotonin, which is a neurotransmitter. More serotonin into the night equals less melatonin at night, and melatonin being produced at a later stage at night. Serotonin balances dopamine, and during sleep this diminishes. In summer, mating season, serotonin will be higher due to the longer light and carbohydrates to deal with the stress of mating season. Types of serotonin dysfunction: excess serotonin or serotonin resistance. Excess serotonin will cause someone to be withdrawn, immobile, very defensive, and may cause them to be depressed. Serotonin resistance actually helps dopamine to escape. And again, dopamine brings everything to a sharp focus. So what happens here is a sensory overload. Someone gets very aggressive and can get into a very paranoid state. Chronic serotonin and insulin levels from too much light makes the brain serotonin and insulin resistance. In this case, it's not low serotonin that's the problem, it's too much. This is caused by lights and carbohydrate availability 24/7, 365 days out of the year, which signals endless summer and the stress of competition for mating. Chronic excess light exposure and carbohydrate consumption equals excess serotonin that never gets turned into melatonin. And remember, melatonin is a very important antioxidant. So heart disease and circadian biology. Serotonin is elevated in excess light exposure in stressful situations, mating season. When serotonin is up, cortisol is up, and the sympathetic nervous system is in overdrive, so you're in a fight-flight state. Chronic serotonin can cause vasoconstriction and blood clotting. Lights on and lack of sleep means serotonin is not turned into melatonin and you have more carbohydrate cravings. Again, this is from excess carbohydrate consumption and excess exposure to artificial light, because we have access to these things 24/7, 365 days out of the year. This excess carbohydrate is turned into triglycerides, body fat for winter and famine, and cholesterol is used to patch up any heart cells against any cell disruption freezing temperatures. But again, we never get winters or famine anymore to reverse these high triglycerides that are caused from excess carbohydrate that were a perennial adaptation for the winter and famine to come. So as we can see here, the major chains of events in cardiovascular disease: high blood pressure, high blood cholesterol, increased clotting factors, blood vessel constriction, lax calcium channels, mirrors all the symptoms of prolonged pre-hibernation syndrome, and these can all be reversed with sleep and cold. So your heart has a seasonal metabolism: summer, glucose; winter, ketones. Because of endless summer artificial lights, our heart never gets a chance to use up the cholesterol that was built up in the pre-hibernation period. Carb intake is still up in the winter. Excess water retention can cause high blood pressure if it is chronic. Insulin is up, serotonin is up, and cortisol is up. Insulin, leptin, serotonin, and cortisol resistance causes excess inflammation. Chronic sympathetic arousal and excess carb intake in the wrong season, winter time, can cause chronic high blood pressure. Chronic high blood pressure will cause chronic shear force and arterial walls. Excess shear force equals excess damage to the arterial walls and inflammation. Because of this chronic inflammation, excess LDL B particle sized cholesterol is left in the circulatory system too long and is at risk of oxidation. Oxidation then can lead to the formation of foam cells, and this can lead to heart disease or a cardiovascular event. And remember, all of these biological mismatches are causing chronic inflammation within the body and this chronic inflammation is a precursor to all chronic degenerative diseases. Other factors with regards to heart disease and circadian biology: endotoxin LPS can be elevated due to a lack of sleep. If we have a lack of sleep, melatonin is decreased. And remember, melatonin, again, is a very important antioxidant. And also, prolactin secretion will be out of whack. So again, we'll have a depressed immune system. Elevated endotoxin LPS can attack the arterial lining. Homocysteine, which is controlled by a cryptochrome carrying blue light. If homocysteine is excessively elevated, this can also contribute to heart disease. So again, the fact that it is controlled by a cryptochrome carrying blue light shows its correlation or its relation to circadian biology. In the book Lights Out by T.S. Wiley, which I will be referencing at the end, she summarizes heart disease and circadian biology with the following: chronic high cortisol from never-ending light, chronic endotoxin LPS from not enough sleep, high homocysteine from too much light, and chronic shear force on arterial walls from seasonal high blood pressure, from carbohydrate water weight, and also serotonin and insulin resistance that never ends. And these factors can have a huge contribution to heart disease. So cancer and circadian biology: obesity, type 2 diabetes, and aging are all correlated with a higher risk for cancer. Chronic carbohydrate consumption because of too much light and availability can cause high insulin and oxidative stress. So chronic carbohydrate consumption can cause oxidative stress. High insulin decreases the production of sex-binding hormone globulin, so sex hormones stay in circulation longer than they should. Oxidative stress will also damage the mitochondria. Lack of sleep because of too much light decreases melatonin, and again, melatonin is one of the most powerful antioxidants within the body, and it'll also disturb prolactin secretion, so overall you're going to have a weakened immune system. Summer equals long light, high carbohydrate intake, high insulin, and high sex hormone production. The wintertime, though, is long darkness, low carbohydrate intake because there is low to no carbohydrate availability in the wintertime, which gives us low insulin and low sex hormone production. So chronic high insulin and estrogen can produce tumours. Estrogen causes new cells to grow, neuroplasm, but they won't turn into cancer cells without the presence of high insulin. Chronic high insulin needs to be present for estrogen to be a problem with regards to cancer growth. Chronic high insulin produces more estrogen receptors. So in Lights Out, once again, T.S. Wiley puts it this way: it's summer, so you eat sugar. Your chronic high insulin levels make you insulin resistant for fat accumulation for the winter that is expected to follow. Just being insulin resistant means that your estrogen has been up as long as your insulin has, which has created neuroplastic growth, new cells, particularly at reproductive sites that are very insulin stimulated. These neuroplastic cells will get hungry enough to mutate to find a way around the nutritional dilemma created by your insulin resistance, and one way it does this is through angiogenesis. So what we're going to look at now is John Beerard and the tropoblastic theory of cancer. Dr. John Beerard was an embryologist, and he came up with the tropoblast theory of cancer. What Beerard believed was cancer acts just like a tropoblast. In fact, Beerard said cancer is a tropoblast. It has the exact same mechanisms of growth: invasive growth factors, integrins, angiogenesis, etc. A tropoblast is a primitive, undifferentiated group of cells, so it's not a matured, differentiated group of cells. What Dr. John Beerard discovered was that pancreatic enzymes will kill cancer growth. What Beerard was fascinated with was that the placenta in a pregnant mammal acted just like a tropoblast, and he believed that cancer was a tropoblast. So what Beerard wanted to find out was, why didn't the placenta, which acted just like cancer, because cancer is a tropoblast, become harmful to the pregnant mother? And what he discovered was that when the embryo started to make its own pancreatic enzymes, that is when the placenta changed from a tropoblast, a primitive, undifferentiated group of cells, to a mature, differentiated group of cells that made it the placenta. Beerard also discovered that misplaced tropoplastic cells into somatic tissues of the body, what he called germ cells, which we now know today as adult stem cells, can also mutate into cancer growth or into a tropoplastic growth. And again, tropoblast is cancer if given the environmental signal to turn into a cancer growth. If we look at the work of Dr. William Donald Kelly, Dr. Kelly believed that there were three primary contributing factors to the growth of cancer. The presence of an atopic germ cell, and these are the same germ cells that Dr. John Berard described. The stimulating presence of the female sex hormones, again this goes back to our discussion about insulin and estrogen, and a deficiency of active pancreatic enzymes. An interesting fact that Dr. Berard believed in was that a deficiency of active pancreatic enzymes could lead to the growth of a trophoblast. Dr. Berard believed that pancreatic enzymes helped to destroy any mutated germ cells, again what we know today as adult stem cells, from turning into a cancer growth if the cells got the adequate signal to turn into a trophoblast, which may turn into cancer. And this is why a lot of nutritional protocols for cancer are vegan or vegetarian type protocols. Excess animal protein consumption uses up a lot of pancreatic enzymes in the digestive process and may lead to deficiency in pancreatic enzymes. And you would want these pancreatic enzymes to potentially help in inhibiting and reversing the growth of cancer. So if you're eating excess animal protein, you may get a deficiency in pancreatic enzymes. Some resources worth checking out would be The Enzyme Treatment of Cancer by Dr. John Berard, The Trophoblast and the Origins of Cancer by Dr. Nicholas Gonzalez, which is just a summary of Dr. John Berard's work, and Cancer Curing the Incurable by Dr. William Donald Kelly. Discovery of fire. This allowed humans to reproduce year-round, decrease melatonin production in the winter, increase prolactin throughout the day, increase reproduction year-round. This helped humans outpopulate all other species. Again, when this initially happened, some people probably died out because, again, this was about the people who could adapt the quickest, the survival of the strongest, if you will. But the key thing here is that the discovery of fire helped humans to reproduce all year round and help us to outpopulate any other species. The next big thing then was agriculture. We went from summer carbohydrate burners, winter fat ketone burners, and then the ice age where we were purely fat ketone burners, to carbohydrate availability 24/7, 365 days out of the year. This allowed us to have larger families and an increased population. And then finally, artificial light, which has been around for the last 100 or so years. We are the only mammals that can control our environment. Artificial light is around us 24/7, 365 days out of the year, and so are refined carbohydrates. This equals endless summer, which gives us high cortisol, which gives us high insulin. We are basically aging at an accelerated rate. We are living 2 days in one. These are biological environmental mismatches. It's all yin with no yang, all feast without famine. And some resources worth checking out would be the book Lights Out by T.S. Wiley and Brent Formby, and also Dr. Jack Cruse's book The Epi-Paleo Reset. That's it for today's episode, guys. If you have any questions, leave them on the Facebook page or on the YouTube channel, or you can email me at atswtv@gmail.com. I'll talk to you soon, guys. Take care, be well, peace.